Next, we'll take a closer look at some of the concepts of the formulas. Let's start by looking at the difference between defining an attribute through a calculation in a formula or in an assignment rule. When the value of an attribute can be obtained by means of a calculation, we usually define it as a formula in the transaction structure. Note, however, that we could also assign the calculation to the attribute by means of a rule. What considerations should we take into account when deciding whether to assign the calculation by means of a rule or by defining the attribute as a formula? We've already seen that if the attribute is a formula, Genexus does not create in its associated table, in other words, the table to which the formula attribute would belong to if it were stored, a field to store the value, since it understands that its value can be obtained from the calculation. For this reason, we say that we consider the attribute as virtual, since it's still present in the transaction structure, but not in the associated table. We can see that in the definition of the table, it appears as a logical attribute. On the other hand, if the attribute value is assigned by a rule, it will still be present in the table simply by assigning a value to it, so it does not become a virtual attribute, but remains a stored attribute. So is it better to use an assignment rule than a formula? No, not necessarily, because it depends on how the attribute will be used. If the attribute is to be used in other objects, and we need to make sure that its value is the actual result of the calculation, then we define it as a formula. As this definition is global to the knowledge base, when any object queries the attribute value, it accesses its calculation and it's triggered, updating the value on the fly. If the attribute value is updated only by the transaction, then its value can be assigned locally with a rule. The attribute is still stored and its value can also be changed through the form. However, the fact that the attribute must be calculated every time is not always an advantage. If the calculation has to be performed on many records each time and has to be done so frequently, it may affect the application performance in contexts where real-time feedback is required. It can also be the case when the formula attribute is calculated from other formula attributes, so that a large number of calculations must be performed to obtain the value. Suppose, for example, that we're calculating the total purchases of a customer of the travel agency as the sum of the invoices made to the customer. The total of each invoice is calculated as the sum of his or her trips, and in turn, the cost of each trip is calculated by a procedure that takes into account the number of attractions visited, the cost of air tickets, the cost of accommodations, and so on. To list the total purchases of all the agency's clients in the last 5 years, it'll probably be necessary to run through many records and perform many calculations, which may affect the response time of the system to obtain the result. In this situation, it would be good to store the result of the customer's total purchases in a table so that if something changes that affects the result, it's recalculated again and the new result is stored. But if nothing changes, the stored value can be used instead of always performing the calculation. We do this by defining the formula attribute as redundant. In other words, although its value can be obtained by calculation, the result of the calculation will be stored in the database, and the value will be retrieved from there in the future. Also, for similar reasons, we can define an inferred attribute as redundant. The definition of redundant attributes will be discussed later in another video. We've seen that we can define an attribute as a formula or assign its value with a rule, but we must also consider how its update mechanism will be in each case. Remember the use of the add or subtract rule, which allowed us to keep the value of an attribute of the extended table up to date, performing the appropriate operation depending on whether we were inserting, deleting, or modifying a record. The attribute of the customer total miles example, updated by the add rule, is a stored attribute, and therefore the value is immediately retrieved. However, because the add rule is local to the customer transaction, as we saw before, only the customer total miles attribute will be updated if the customer transaction screen or a business component of the transaction are executed. If we want the value of the customer's total miles attribute to always be kept up to date, we should define it as a formula, in this case, a sum formula that adds the miles of each trip to the customer's total miles. Although defining the attribute as a formula ensures that it's continuously updated, we lose the possibility of it being stored, and in order to obtain its value, we may cause the performance problems mentioned above. To solve this, we could define the customer total miles formula attribute as redundant, and it will become a stored attribute. But when is this attribute value updated in the table? When we define a formula attribute as redundant, Genexus automatically creates procedures in charge of updating its value and storing it in the database. In the example we saw, when through the customer transaction, or its business component, a customer trip is inserted or deleted, or the value of the customer trip miles is affected, the sum formula is recalculated, and the new value is stored in the customer table. When the value of some of the attributes that are part of the calculation of a redundant attribute is modified from the form of a transaction or from a business component, Genexus triggers the procedure that updates its value. Therefore, from the point of view of the update, and that the attribute is stored, updating the attribute by means of an add rule and defining it as a redundant formula are equivalent solutions. However, there are several differences to consider between using one way or the other. Now let's look at some comparative tables to help us consider the pros and cons in each case. First, let's analyze the advantages and disadvantages of using an add rule. The advantages: the attribute assigned by the add rule is always stored, so its value is immediately retrieved. The attribute can still be edited in the transaction's form. The attribute is updated each time the rule is triggered. In other words, when a record is inserted, modified, or deleted from the transaction where the rule was defined, either through its form or through business components. The add rule knows the operation to be performed depending on the state of the transaction. In other words, it knows if it has to add when a record is inserted, subtract if it's deleted, or modify when an update is performed. The update takes a very short time, since only tables belonging to the extended table are accessed. The main disadvantages are: the add rule is not triggered when a table record is inserted, modified, or deleted through a procedure object, so in this case, the attribute value is not updated. And it's not possible to force the rule to be triggered on demand, so it's not possible to force the attribute to be updated. Now let's look at the advantages and disadvantages of defining a formula attribute as redundant. The advantages are: the attribute defined as a redundant global formula is always stored. It's updated when any attribute that is part of the calculation is modified, or when a record of the transaction where the formula attribute was defined is inserted, modified, or deleted, either through the form or with business components. Redundancy procedures know the operation to be performed to keep the attribute up to date. In other words, they know whether they have to add, subtract, or how to modify the value. And it's possible to force the triggering of the redundancy update on demand by means of special procedures that Genexus creates when we define an attribute as redundant. The disadvantages are: the attribute is read-only in the form of the transaction where it was defined. Even though with redundancy it's stored, we cannot edit it. The redundancy update takes a long time, as it involves running several procedures and usually accessing several tables. When a formula attribute is defined as redundant, the size of the KB is increased due to the addition of the procedures created to maintain redundancy. And, if anything in the formula definition changes, Genexus must keep the redundancy procedures up to date. Therefore, as we said before, we must consider what's better, whether to update the value of the attribute by means of a rule, or by defining it as a redundant formula, depending on the considerations we've just seen and how we will use the attribute. In the following videos, we'll study the different types of formulas that we can define.